This is Laura Duncan from CSMS. Today we're going to talk about common Pythagorean triples. Remember that the Pythagorean theorem is used to find the missing side of a right triangle. A and B are the sides that form the right angle, and they are called the legs. C is called the hypotenuse. It is also the longest side, and it is opposite the right angle. Now let's use the Pythagorean theorem here to find the missing side of each right triangle. First things first, do you know where your hypotenuse is? Well, it is opposite the right angle. So this time we are looking for the hypotenuse. It is not given. So what is given is 3 and 4. Those are the legs. We will substitute them into the equation of a squared plus b squared equals c squared. 3 is a, so we'll have 3 squared. 4 was b, so plus 4 squared equals c squared. 3 squared is 9. 4 squared is 16. That is equal to c squared. We can simplify further. 9 plus 16 is equal to 25. We are still not complete because we need to isolate the c completely. How do we get rid of this squared? Remember that we have to do the opposite. The opposite of squaring is taking the square root. So c is equal to 5. Box your answer. Then check for reasonability. Your c is your hypotenuse. It must be the longest side. So looking back, is it the longest side? Yes, it is. Moving on to number 2. Where is your hypotenuse at this time of night? We'll look for the right angle. The hypotenuse is opposite the right angle. So our C is 15. So that means 12 is one of the legs. It doesn't matter where we put it. It could go in A or B. But if we put it in B, we're looking for A. If we put it in A, we're looking for B. So make your choice. And now let's substitute and solve. This is the Pythagorean theorem. So we're looking for A, and then we'll square it. So A is 12, so we'll substitute it into the equation. We're looking for B squared, we'll leave it as it is. And then C is equal to 15, so we'll substitute 15 and then square it. Now let's simplify and solve. 12 squared is 144, plus B squared is equal to 225. Now how do we isolate our B? To isolate our B, we do the opposite. Since 144 is being added, we will subtract 144. But what we do to one side, we do to the other. So this cancels out, and B squared, 81. We're still not finished isolating B because it still is squared. So we must do the opposite. The opposite of squaring a number is taking the square root. So the square root of 81 is equal to 9. Box your answer. Go back and check for reasonability. To check for reasonability, we're looking for the hypotenuse. Is the hypotenuse larger than each of the legs? And since it is, we have a good chance of being right. All right, another example using the old-fashioned way, and then we'll talk about a way that will make your life easier. So first, find your hypotenuse. The hypotenuse is the one that's opposite the right angle, and it is the longest side. So that means 50 is the hypotenuse, and 30 can be either A or B. Please pause the video here and try to finish out number 3 on your own. All right, we have an answer of 40 for our B. Is it reasonable? Now let's move on to something that will make your life easier. To make your life easier, we want you to notice the pattern. Notice something special about the first 3 examples. Try to find the special ratio. In example number 1, the side lengths were 3, 4, and 5. In example number 2, the side lengths were 9, 12, and 15. We could look for the scale factor. What's that special ratio? Or what did we multiply the first set of numbers by to get the second set of numbers? So in each of these, each of the sides were multiplied by a scale factor of 3 to get the lengths of the other sides. Look at example 3 and see if you can find the scale factor there. The scale factor in example 3 is 10 times the original side length given. So let's talk about those Pythagorean triples. The definition of a Pythagorean triple is 3 whole numbers in which a squared plus b squared equals c squared. There are several common Pythagorean triples listed below. Now what I want you to remember is the largest number must be the hypotenuse c. So you may be wondering, how does this make my life easier? Well, if I have a right triangle and the two legs are 3 and 4, then I know without doing the Pythagorean theorem that the hypotenuse is 5 because it is a common triple. Instead of showing the solving of the equation as we have in the past, if you know it's a common triple, then you will write down the common triple as a way of showing your work. Before we move on, remember all of these largest sides must be in the place of the hypotenuse. Now the really neat thing about this is that these numbers will work on their own or in any ratio that will simplify to one of these. To simplify these numbers, we will find out what they all can be divided by, and then we can match them. If they match a triple, then those numbers will form the legs and hypotenuse of a right triangle. Look at the next example. All of those numbers can be divided by 2. They are divisible by 2. And it would simplify to 7, 24, 25. Go look at your triples. Is that one of the triples? Here it is. That means yes, this group of numbers will form the sides of a right triangle. Let's put that into practice. We'll find the missing side for each right triangle using the Pythagorean triples. We'll circle the triple that represents the triangle. First, I like to put the numbers in some sort of order. I'm going to leave a blank for my b because I don't know what it is right now. However, I know the hypotenuse has to be 39. It is the largest side or the longest side. Now, ask yourself about these numbers. What do they have in common? 15 and 39 are both divisible by 3. So if I divided by 3, then I would have a 5, a blank, and a 13. Is there a triple that matches that? Well, here it is. 5, 12, 13. To use this triple, instead of using the Pythagorean theorem to find the missing side, we start with our common triple of 5, 12, 13. Now, it's kind of like working backwards. You know that we divided by 3 in order to find our common triple. Now we have to work the other way. What are we going to do to the 12 to find this missing side? Because the missing side is not 12. Well, we're going to do the opposite. If we multiply by a scale factor of 3, you can see we end up with our 15, which is what we started with. 12 times 3 is 36, and 13 times 3 is 39. So 36 is our missing side. On to our next example. We have a leg of 6, a missing leg, and a hypotenuse of 10. Now, check for divisibility. Both of these numbers can be divided by 2. The reason that we're doing that is so we can see if this will simplify to one of our triples. So we have a 3 blank 5. which common triple does it match? It matches the 3, 4, 5. So I know that this is a 4, but 4 is not my missing side. The 6 blank 10 is a larger triangle. It's larger by a scale factor of 2. So if I multiplied each of these legs by a scale factor of 2, then I will find my missing side, and the hypotenuse will stay at 10. So my missing side is the one that we were looking for. The missing side is 8. On this one, notice that the hypotenuse is the number that we're missing. So we're going to write them in the correct order so we know that the hypotenuse is the one that is missing and it's on the end. Now you look for what are these numbers divisible by? How can we simplify them so that match them to a triple? So we find out what they have in common. I can tell you right now we will not find a matching number. Why? Because I didn't divide by the largest number that they have in common. So let's go back and fix that. Now if you made the same mistake I did, you could go back and start over again like I'm doing, or you could divide and then divide again. So 27 divided by 9 is 3, and then we have a 4, and then this one has to be a 5, so we have a 3, 4, 5. Since the scale factor was 9, I will multiply whichever the missing side was by 9. This was the hypotenuse, and I know that the missing side is 45. We've worked through these problems. This is the way that you will show your work. You will write the triple, pause the video, and do the 2 questions to the right before we move on to the 3rd page. Let me check in with you and make sure you found the triple first. The common triple is 7, 24, 25. Now let's say that you didn't do it that way. You did something 21 and then 75. And then you simplified by 3. Then you'd end up with 7, 25. Would you still be able to tell that this and this are the same thing because A and B are interchangeable? Please be sure to check your answers before moving on. In our last set of problems, we'll tell whether each set of numbers satisfies one of our common Pythagorean triples, and if so, which one. So let's look at number 1. We first see if they have anything that can simplify them. What are they divisible by? These 3 numbers are divisible by 3. That would simplify to 5, 12, and 13. Go back, check your common triples. Is it a common triple? Yes, it is. If it is, that means this set of numbers can form the sides of a right triangle. Let's go on to number 2. What are they divisible by? What do they have in common? They can be divided by 2, but will it be enough? So we have 8, 15, and 17. Are those common triples? Why, yes, they are. Go on to number 3. Here I'm going to make what I call a paid mistake. I am going to divide each number by 3. And when I do, I find that I have 9, 12, and 15. Well, that is not a triple. But perhaps you'll look at them again and you'll say, oh, 9, 12, and 15 have something else in common. They have a 3 in common. So once you get it completely satisfied where they do not have anything else in common except 1, then you'll see and be able to determine if it is a triple or not. On number 4, you can start looking for common numbers that they are divisible by. These 2 are divisible by 2, but this one is not divisible by 2 because it's not even. There is not any other number but 1 that can be divided. So these numbers are already simplified. Now, are those numbers a common triple? No, they are not. Please pause the video at this time, do numbers 5 through 8, and check your answers. Good job. Now let's go forth and use some triples. Hope you know where your hypotenuse is.